Welcome back as we move on to the first stage of assembling a worm drive reduction unit. We shall assume that the carrier bearing cones of both the worm shaft and the wheel shaft have been installed onto the respective shafts in the appropriate manner. Assembly commences as we first install one of the worm shaft carrier bearing cups into its respective counterbore within the casing. Note that these bearing cups are a firm press fit, and a soft drift will be needed to tap them into position. The worm shaft is next carefully positioned into the casing. An assistant is useful here to help support the shaft whilst the opposite bearing cup is installed. The cup is tapped fully into position until the shaft is totally supported on its bearings. Now the relevant oil catchers, along with their respective original shim packs, are replaced according to the markings made during our dismantling procedure. You will notice that we have not yet installed the oil seals, and for good reason. Inevitably, we will be removing the oil catchers again for purposes of setting the shaft end float, and we don't want to risk damaging new seals. We must fit both oil catchers and then nip the set screws to finger tightness only. At this time, you might find that a gap exists between the case and the oil catcher. This is because our bearings are not completely seated. To seat the bearings, we must carefully nip up the set screws in small increments using a star pattern tightening sequence. Frequent rotation of the shaft must be made during this process to ensure that no binding occurs. When both oil catchers have been firmly secured, and after ensuring that the shaft still rotates freely, we will check the shaft end float. The most accurate method of assessing end float is with a dial test indicator, which has been set up here using a magnetic base. Movement is created using hand pressure upon the shaft. The actual end float permissible is provided by the manufacturer, and for this you will require their specification. Adjustment of the end float is made by removing or adding shims to either oil catcher. Removing shims will reduce the end float, and adding shims will increase end float. Rotation of the shaft after the removal or fitting of shims is essential to ensure that the bearings seat correctly. Having established the specified end float, the oil catchers can be finally installed. A bead of liquid gasket sealer is recommended by this unit's manufacturer, as no gaskets are used on the facings. The oil catchers are replaced, along with the shims, and the set screws tightened progressively in the proper sequence. Final tightening should be made using a torque wrench set to the specified torque for the particular sized thread. We move on to attend to the replacement of the worm wheel and its related parts. Once again, we'll be needing the help of an assistant or suitable lifting tackle. A few turns of the input shaft will ensure that the worm drive and worm gear are engaged. At this time, we are concerned with setting the specified bearing end float. This is done by installing the oil catcher and rear cover retainer with their original shims. These are to be fitted using 3 set screws only at this stage. End float must be established according to specification using a dial test indicator. Note that we only use hand pressure in order to create the float. Using levers or pry bars is not recommended, as false readings will be obtained. Again, we remove shims from either side or both sides to reduce the end float, or add shims to increase the float. The specified wheel shaft end float is obtained from the manufacturer's data. After each and every shim adjustment, the unit should be rotated to settle the bearings. After the break, we shall be demonstrating how to check and set tooth contact.